The next thing I'm just going to talk about really quickly is why any of this variation even happens. Well, the variation all has to do with the tilt of Earth's axis. So Earth orbits around the sun on a flat plane called the plane of the ecliptic. However, Earth's axis, that's the line that goes up and down and actually represents the Earth's rotation, is actually at an angle relative to the plane of the ecliptic. And it's actually at an angle of roughly 23.5 degrees. And this is probably a more exact number, 23.27 right here. But basically what's happening is as the sun is revolving around, as the Earth is revolving around the sun, forgive the bloopers, as the Earth is revolving around the sun, basically what's happening is the amount of sunlight received in one hemisphere is changing relative to the other. So during the winter solstice, what actually happens is the southern hemisphere receives a larger portion of sunlight than the northern hemisphere. And you can actually see that on this image right here. If you actually take a look, more of the southern hemisphere is lit up than the northern hemisphere. During the equinoxes, both hemispheres are receiving the same amount of sunlight. And then during the summer solstice, this is in June, the northern hemisphere is receiving more sunlight than the southern hemisphere. And there's actually a few really cool images that they show that actually can help with this. So here's the first one, and this basically shows the fact that in September, this is the 23rd of September, so this is the autumnal equinox. This is the first day of fall here in the northern hemisphere. Basically what's happening is if you take a look, both hemispheres are actually receiving the same amount of sunlight. And as a result, everywhere on Earth, with the exception of the poles, is experiencing a 12-hour day. Now, if you're at the poles, you're either experiencing sunrise or sunset. In this case, what's actually happening is the sun is actually going to begin to travel south. And so the North Pole is actually experiencing sunset, while the South Pole is actually experiencing sunrise. Meanwhile, this is actually that same image, but now for December, specifically December 21st. This is what's called the winter solstice. And if you actually notice, in this case, the southern hemisphere is getting a lot more sunlight than the northern hemisphere. But there's one other interesting thing to notice. As the Earth is rotating like this, there's some portions of the Earth that actually will never cross the terminator line into the sunny spot. And these locations are near the poles, and specifically everywhere north of the Arctic Circle is getting 0 hours of daylight on this particular day. Meanwhile, if you actually look down near the South Pole, there are locations near the South Pole that are also not going to cross the terminator line into darkness. And so these locations are getting 24 hours of daytime. And so on the 21st of December, the winter solstice, all locations north of the Arctic Circle are in forever darkness. And all locations south of the Antarctic Circle, down here in the southern hemisphere, are experiencing never-ending daytime. And then 6 months later, the opposite is true. And basically what's happening here is now the northern hemisphere, and everywhere north of the Arctic Circle, is now going to remain west of the terminator line. And so it's never actually going to cross over into darkness. And so they get 24 hours of day. Now imagine that. Imagine trying to sleep at night if you live somewhere north of the Arctic Circle. I'm glad I don't experience that. On the other hand, locations south of the Antarctic Circle, here in the southern hemisphere, these locations are east of the terminator line, and they're never going to cross over into the sunrise. So they're going to be dark during this time. But again, as the Earth continues to revolve around the sun the position of the sun changes, and hence what eventually happens is sunrise happens at those locations, and then voila, they're now either in permanent daytime or permanent nighttime until the next season happens. So that's it for this lab. Please feel free to use this lecture as much as possible. I do apologize for some of the bloopers, but I do want to get this video to you, and I just hope that it's helpful for you. If you have any questions or need any help, please don't hesitate to reach out to me. All right, best wishes on this lab, and yeah, let me know if you have any questions.